So thanks for coming to this talk. My name is Chris Beams. This talk is called "The Revolution Will Not Be Centralized." This is perhaps a bit of an unusual talk for Spring One. It's certainly an unusual talk for me at Spring One because this talk has nothing directly to do with Spring or Groovy or Grails. You probably gathered that if you read the abstract. Definitely has something to do with Java, and we'll see that very quickly. But yeah, something new. So some of you may know that I worked for the Spring team, worked for VMware and Pivotal for years and years, and I left that position about 3 months ago. And one of the big reasons that I left, very difficult decision as it was I saw what was happening in the Bitcoin space, and I just really thought to myself, there's something going on here that deserves one's full attention, right? So I thought I'd see what it's like to research and dive in completely. I'd been watching it for a couple of years, and very closely for a number of months, and decided to take the full leap. So I've been basically in a kind of research mode for the last few months, and hopefully some of what this talk is a kind of a gathering up of what I've learned and maybe how it applies to what we do and to our world and so on. So you might know Bitcoin better as magic internet money, right? It sometimes goes by that term. We'll see. This talk isn't entirely about Bitcoin, by the way. But you'll see that it kind of weaves like a thread through a number of the topics that I'm going to touch on, where decentralization is actually the overall topic. But since we're going to be coming back to Bitcoin a number of times throughout, it's a good idea to see like where people are at with it and what people already know. So I'll just have a show of hands, and you can keep your hand up, and then you'll put them down question after question, depending on whether the question applies to you. So how many have heard of Bitcoin before this talk, right? Yeah, OK, so keep your hands up, right? Vast majority in the room. How many have done, again, before this talk, have done a bit of research? You know something about it. Maybe you formed an opinion one way or the other about it. Almost every hand up. OK, good. So how many have, in some form or another, a Bitcoin wallet? All right, at least half the hands, probably closer to 3/4, somewhere in between, right? OK, and how many, keep your hands up, how many have spent Bitcoin on something? Yeah, so even some with the wallets, hands went down, right? So you've purchased or been given Bitcoin in some way, but haven't actually spent it. OK, and so the ones with their hands up, last question. How many are running a full Bitcoin node? Like you're running Bitcoin Core on your machine all the time. OK, 1, 2. OK, you guys might know more than me, right? Yeah, OK, well, that's actually exactly what I expected. Basically, most everyone has heard of it. Many fewer have actually interacted with it or done anything with it. That's not too surprising. I think that's totally representative of the state of things, generally, among technologists even, right? And among lay people for sure. So let's fix that right now. Shall we? How many people saw this tweet yesterday? Yeah, and how many actually went through those 3 steps? You need to have at least a few. OK, so hands high. 1, 2, 3, 4, 5, 6. OK, good. Good. That's actually a pretty accurate reflection of how many clones I saw, because I did a couple, and then there are 6 others. So I think that's going to be just enough. So what we're going to do is we're going to use a library called Bitcoin J, which is a really fully featured implementation of most of the Bitcoin protocol in Java. Right? When you run the default Bitcoin client, Bitcoin Core, on your laptop or your desktop, you're not running Bitcoin J. You're running a piece of C++ code, right? But if you're using almost any other wallet or many of the other wallets, a wallet like Multibit or a wallet like Hive, which I'll show you in a moment, underneath the covers very often is Bitcoin J. So people are doing all kinds of different things with Bitcoin J. It's really flexible. And we're going to do something really simple but hopefully fun with it today. So this is a Bitcoin address, right? Pretty sure most everybody knows the form of that. What might not be so clear to everybody is that what a Bitcoin address is a public key, right? It's especially encoded public key, right? It's encoded with base 58 encoding and so forth, has some built-in checksums and so on, but it's essentially a private key, right? So at some point, some random number generator created a gigantically large number, created a public key, and of course, created a private key, right? And I'm truncating this one here. That's all made up. That's not actually a part of a private key, right? But just to show you, there's always that key pair there. So what we're going to do is we're going to use Bitcoin J to generate a Bitcoin address. Actually, we'll generate probably many millions of them, even among the 6 of us that'll run this program. So we're going to run generating address after address after address after address after address at about the rate of 20,000 per second, keys per second or so, until finally you randomly and luckily land on a winning address. So how many are familiar with the idea of a vanity address, a Bitcoin vanity address? Yeah, a couple, right? This is just a silly idea. It's basically equivalent to people who get vanity license plates, right? Doesn't serve much of any purpose, except it gives a big, intimidating string of letters and numbers a little bit more, human friendliness. So by searching for this token, that 6-letter token would take us probably hours and hours and hours together to find, because it would just be so unlikely to find that combination of letters also in that position, right? We're going to try to find a token at the beginning of the address, right after the 1. The 1 has to be there. But we'll try to find a token, and I'll show you what that token will be in a minute. And hopefully it'll be just difficult enough that with the 6 of us working together, 1 or 2 of us will get lucky, right? And so the first one, well, here's the steps, right? Here's what we'll do. So the 6 already have this repository cloned based on the instructions. And so I'm going to make a change to a piece of code. I'm going to push it. Demo God's willing, wireless God's willing. And then you'll see that push happen, and you'll immediately run this command. So starting right now, get that queued up if you don't already have it in your terminal. Make sure you're ready to hit go when the time is right, yeah? That offline switch is important, right? You don't want to have to go check repositories for jars you already have and so on. That would be wasteful. OK, so that's going to be step number 1. I'm going to go through all the steps before we do anything. Step number 2 is that program's going to run. It doesn't look like it does anything. It just sits there silently at the console. But when it finally finds a match, the right token, the right vanity address, it'll print out the address, and it'll print out the private key. So keep that private key safe, right? Don't email it to yourself. Copy, paste it, put it in a file, right, and promise yourself that you'll do something actually secure with it as soon as we leave the room. OK, so that's going to be step number 2. Step number 3 is you email me that address. And the first one to show up wins. So the 4th step is profit. So I'm going to give away 10,000 bits. Anybody know what a bit is? It's 10 to the minus 6 bitcoins. So I'm going to give away 10,000 bits. That's about $5, yeah? Yeah, and if we have a very close tie, then maybe there's a little bit extra. But what's quite likely, actually, is that just one person will get it, and then some others will come in. Somebody will just get lucky. OK. So, make sense? Any questions so far? Right. Yeah, you'll actually see, so the question is there an upper limit on the number of cores you can use? Well, the limit is whatever the code that I wrote does, unless you think you can change it fast enough to beat everybody, and it might help, right? except the code is already set up to maximize, use all your processors. OK, so let's do it. OK. If the person next to you starts furiously typing while I'm explaining this code, you should stop them. OK, yeah. In fact, I'm going to increase the font size. It's been a while. Where is that? Idea people. Yeah, it doesn't actually work on my machine. Yeah, that often doesn't actually work out, but we'll see. Not bad. OK. OK, so a quick explanation before you run code that you have no idea what it does on your machine, right? OK, so we're importing Bitcoin J classes, right? The first thing here is that the address that we're going to generate is going to be one that can work on Bitcoin's main network, right? So Bitcoin has 3 networks, basically the main network, the test network, and then there's something called the regression test network, and they all have a different form of address, right? So we're going to create a real address that we can do real transactions with. Number of processors is just what it sounds like, so it'll ask your machine how many cores you have, basically, and we'll spin up the requisite number of threads. Yeah, see, presentation mode isn't going to let me out of here, is it? Again, OK. Right, so we're going to keep a flag, right? Have we found one yet? Should we keep searching? True. Set up an executor that has just the right number of available threads in the pool. And then for each one of those processors, just execute this runnable, right? If we're to keep searching, generate a new key, right? So this is the most important part. Generate a new EC key. The EC there is for elliptic curve, right? The random number that we're going to be generating is going to be done with elliptic curve cryptography. And then we'll create an address from that key, right? So do all the work to base 58 encode it and make it look like a Bitcoin address. And then spit it out, right? And also spit out the private key in the correct format. And by in the correct format, that private key that gets dumped out will be all yours to import into a wallet, afterward, assuming that you win. But just take note, right? We're not going to do anything with a wallet. You're just going to generate an address, and then I'm going to send some money to it. So that's kind of an important point that we'll talk more about in a second. OK, so gentlemen, are you ready? OK, so this is what's changed from what you guys cloned. So nothing more, nothing less. And push. Ready? Go. And somebody just raise your hand or shout out once it starts going, just to know that everything's OK and the wireless is OK. What's up? Okay. You got one. You actually already printed out an address. Really? And Rawson? You're still spinning, though, yeah? Oh, you know what? You know what? No, I promise this is all part of the plan. Here's why. Here's why. It's actually really useful. Right, so look at the logic there. So this was a test run, everybody. Right, so if the address contains the target, right? So S2GX could be anywhere in there. So let's do No, I'm fine, actually. Thanks. Thanks a lot, though. All right, so we'll do starts with. OK. Whew. Well, just in case anybody else was typing that ahead of me. No, I just wanted to be honest. OK, so somebody shout out again once you've got that pulled down. That one should take a little longer. Could easily get lucky, right? Could take just 2 seconds. Oh, make sure you have an email ready to send to me as well. You don't want to lose because you didn't have an email ready. Chris@beams.io. So this is a bit of a gamble. On my machine, this is 4 cores. And when I try to have a matching the beginning of the string S2GX, it usually takes some minutes, right? But between the 6 of us, it should be fairly quick. Oh, you hear the fans go up? Yeah. OK, so yeah, so everybody's churning, right? Depending on how many cores you have, somewhere probably between 5 and 20,000 keys per second, kilokeys, right? 20 kilokeys. Yeah. And this might be a little bit reminiscent if you understand how mining works. We're not mining, right? We're not mining for Bitcoin, but we are doing something kind of similar, right? Spending a bunch of energy to try to solve a puzzle. Yeah. What's that? Wow. Good job. Good job. Thank you. Wow, that would have been really painful like 10 minutes from now. Mm-hmm. Yeah, so we would be at. Yeah. What's that? We will have to do it again, yeah. Because it'll never match. Yeah, exactly. Let's try that. So while you guys do that, I'm going to test it. We'll just try to match an S, right?
I think we need to organize your code.
OK, well, that seems to work. That's funny. Yeah, sure. I won't pay myself, though. Sorry, which?
Do I need a network connection here at all? What's actually
Once you've pulled it, you don't. Yeah, it's just generating keys. It's just working with whatever random information it can get from your machine. Right? Yeah. No, not at all. Don't anybody ever use that address. The private key is out there, right? So this was just while we're waiting. And somebody just shout once you found it. There's a few reasons that I wanted to do this demo. Hopefully it's kind of fun and so on. But really, one of the biggest points is I think there's a real misnomer around Bitcoin, and that's the coin part. It's very understandable why this metaphor exists, right? You can send somebody a coin, you can buy something with a coin, you can put a coin in your wallet. But of course, you never actually do, right? You never actually have a Bitcoin. You never actually ever give anybody a Bitcoin. All you're ever doing is dealing with these public and private keys to sign transactions, right? To sign a transaction that says, this Bitcoin, which only ever exists on the blockchain, which we'll talk about in a moment, I want to transfer ownership of that Bitcoin to somebody else. It's actually a much more accurate metaphor to think about. And as we talk about, when we talk a little bit later about exchanges and things like that, Bitcoin exchanges and crashes and theft and so on, I think it serves people really well to really understand the nature of what it is that's in your wallet, right? And it's really just these keys. So the question of how do I keep a Bitcoin secure is really a question of how do I keep that number secure? How would you keep a string of letters and numbers secure if it was worth $10,000? What would you do? What kind of file would you put it in? What kind of disk would you put it on? Would you put it on a machine that's connected to the internet at all, right? But there are no coins here, right? There's just addresses. So we'll see what happens with wallets, right? With wallet design. Will it keep the coin metaphor going? Or is that kind of a lossy metaphor? Will we someday think more about securing keys? Because that's kind of the more accurate thing. OK, so we're probably a few minutes in. No hits. We shall see. Well, we can also move on with the slides. You six have to keep an eye on your machine. It's funny, testing this, which I actually did do, even though I didn't have automated tests. I would sometimes see it happen just in a split second, right? It really is random, and the best you can do is kind of calculate probability. How likely is it that this will hit in how much time?
How much will it block up the source of entropy?
Again?
So if the entropy of the machine is not there, will it get blocked?
Yeah, so the question is, if there's no entropy on the machine, what'll happen, basically? Yeah, if the pseudo-random number generator that's on your machine suddenly runs out of entropy, well, of course, there's something really, really fundamentally wrong with that whole stack that you're sitting on top of. That should never happen. But if it did, you'd just keep on generating the same key pair over and over and over again. And our program isn't very helpful about telling you something like that. So you would just be stuck. Yeah. Yeah. Just one. OK, so just one more thing before we move on, since we're on the topic. We're trying to match 4 letters at the beginning of the address. And if you think about it, what's to stop you from running a program like this and trying to match an entire existing address? Just go look at some kind of blockchain explorer and see which addresses have the most Bitcoins in them, right? There's the bitcoinrichlist.com, I think is the name of the site, right? You can just go see, oh, that one has a few $million worth of Bitcoin in it. I'll just try to generate a vanity address that matches that, right? Which is, in principle, totally possible. It would just take longer than the heat death of the universe to ever get a match, right? You could get extraordinarily lucky, but we'll all be dust before anybody does, certainly. So that's why the number is so big, right? That's why the addresses are so long, is to prevent that possibility from ever happening. Okay, yeah, a question?
Given that, pretty much a few decades ago, that's cryptography implementations are pretty much perfectly secure today. How can you guarantee that tomorrow I won't come up with an algorithm that'll drastically increase the
Yeah. How can we guarantee, so the question is, how can we guarantee that someone doesn't come along tomorrow that either finds a hole in this cryptography, right? Or in fact, there was a backdoor all along, right? Well, nothing. It's it's possible, right? I mean, in this way, people talk a lot about Bitcoin being trustless, You can transact without trust and so on. But in this way, we really do trust one community a lot, right? And that's the cryptography community. And that's definitely rocket science beyond me. But it's the review process there that really matters.
It's not necessarily that there would be like a problem with it. It's just that the history of photography, I mean, way back in the moment that I just quickly over about one letter, one cipher was good enough. But it's one thing that's shown all along is that like people will come up with what they think is a great algorithm, and then a few decades or maybe sometimes not even that long.
Yeah.
Later, somebody will come along and just break it.
Yeah. Well, I mean, the ultimate specter here is quantum computing, right? Because if a proper quantum computer came online, on day one, it would solve every Bitcoin address's private key instantly, right? So our only hope is that we can anticipate what quantum computing looks like before it actually hits, and that we've got post-quantum cryptography ready to go, right? And Bitcoin gets, fitted for that, right? Actually, so I'll just hold the questions and we'll go on just to make sure we stay okay on time. But interesting, the difficulty is pretty high, right? So just somebody shout when you get it. So the next thing that I'm going to do, right, and hopefully somebody will find the address soon so that we actually do it. A warning, right? Does anybody remember this? Anybody ever actually use NCSA Mosaic, right? Yeah, lots of hands go up. The software I am about to show you, if you haven't seen it before, may remind you of this, this level of primitiveness. It's a common thing if you're reading about Bitcoin or you're learning about Bitcoin that you hear people comparing it to the early web, right? Bitcoin today is like the web in 1994 or something like that, which I actually think is a very apt analogy in many ways. But how it looks, how it feels, how functional or not the software is, right? How user-friendly or not it is absolutely apt for that metaphor. So so let's take a look. I've actually got 3 wallets up here. So just by show of hands among those who had wallets, how many are multi-bit users? If anyone. 1, 2, I would say I'm a multi-bit user. And how many are running Bitcoin QT or now called Bitcoin Core? Yeah, those who keep a full node certainly are. Yeah, a few, hands go up. And then how about anybody using Hive? That's a Mac OS only. Electrum? Yeah, a couple hands. Any others? Just shout out. You might have covered it. Yeah, so just a quick survey, right? So here's a wallet that I set up in multi-bit, which might look familiar, right? It's a Swing app. It's a Swing app, and underneath, Bitcoin J is doing all the heavy lifting. And so it just has, about 39,000 bits, right? Or 0.039 Bitcoins, right? So that's the reward money if anybody ever actually hits the target. And you can see another vanity address there, this one beams, which I generated a while back, just for little demos like this or whatever. So that's one wallet. If you haven't seen it before, we could send, receive, take a look at the transactions that have already happened. This is one that I sent to myself just earlier today, just getting ready for the demo. I sent myself the reward money basically, And I sent it to myself from another wallet, another address that I have over here. Not that one, but Hive, right? And so Hive is probably the most modern looking, right? It does a pretty good job of UI and so on. Just one moment. Right, so I sent from that address over to my one Beams vanity address so that we'd have something to spend. Right, and this is really minimalist UI here. It's really just about that simple, right? You can send money to an address and so on. It's trying to make it as user-friendly as possible by in many ways removing features. One issue that I have with this wallet is that it actually only has one address. So that one address that's in there, this one MW, if you can read that, is the only one that I can send and receive money from. I believe, unless something new has happened with Hive, I could be out of date. But that's a pretty bad practice, right? Anyone know why is that a bad idea to reuse addresses? It enables tracking, yeah. Yeah, it basically enables, just like we have traffic analysis on the internet for plain text protocols like email and so on, we have transaction analysis in the Bitcoin world, right? Because every transaction is public. We'll talk more about that in a moment, but you're anonymous or pseudo-anonymous as long as no one knows that you have that address. Too late for me. It's going to be on the internet soon, right? It's on a video. So anybody who wants to plug that into a blockchain explorer, which we'll see in a moment, now knows that it's me and can track both forward and backward, right? Every time I transacted in and out of that address and every transaction before it. A lot of people, often you hear people talking about Bitcoin, oh, it's this, private money that's for criminals and so on and so forth. It's actually very much the opposite, right? If you're not being extremely careful, by default, it's anything but anonymous. You actually have to go to great lengths to make sure that it's anonymous. Right, so let's take a look at blockchain.info. Right, so notice that this is the first time that we're hitting a website of any kind. Everything we've been doing so far has just been on our local machines. All the wallets have been local. All the code that's running is local. Nothing's talking to the web other than the git pull. That's going to be a theme that I'll come back to a few times, right? We're doing, it's all this peer-to-peer network. So we shouldn't really have to go to websites very much, right? We shouldn't have to store our Bitcoins in web wallets. Every hack you've probably heard of, or most of them, thefts of Bitcoin, which is really theft of private keys, typically happens at web wallets and web exchanges and so on, right? Centralized entities that are fallible and people can break into, right? Can't break into the blockchain, but you can definitely break into Mt. Gox. Okay, so there's that address that you guys just saw. And indeed it has this much of a balance waiting for the lucky winner, if anyone ever hits, right? So when we do that, and I send some money from this address to whichever ones you guys come up with, then we'll be able to watch that transaction happen. And maybe the thing we should do is actually reduce the difficulty a little bit. What do you guys think? Pretty surprised, actually. That'll be way too easy. Yeah, equivalent, yeah. Anybody see any issues with that before I run it? Shocking. Shocking that nobody got it yet. Okay, if you guys didn't see, you should be able to go. So basically, somewhere in the first 9 characters, right after the 1. Mm-hmm. Got it. Did you email it? Aha. Okay. Okay. Email it. We'll do 2. We'll do 2. If you guys email it before somebody else does. Yay. All right. Okay, so these ones we don't need. That was 306. Okay, so these are the good ones. These 3. Okay, so that's the first one. Coming in at 306, Martin, lucky winner, and Gary. So close. One character off from the front. Okay, sorry, Brian. Okay, cool. So let's do it. So we'll take that address and you can send it through any one of these wallets probably, but if you, yeah, so you noticed before that this wallet has, let's say it correctly, right? I've imported the private key for this address, 1beams. I've imported that private key into this wallet. So this wallet is now capable of sending and receiving transactions and so on, analyzing what transactions have happened, telling me my balance on that address. And it's, most critically, it's capable of signing new transactions to transfer Bitcoin from that address off to somebody else. So that's what we're going to do, but just for good measure, let's also look over here. So Bitcoin Core, right, the original Bitcoin client, has the same balance as Multibit does, 0.0309. Or it's actually very close, right? But the reason for that is that this wallet is also, the private key for 1beams, et cetera, has also been imported into this wallet. So I'm just reiterating this, right, to kind of drive home the point that the bits or the Bitcoins on that address, if you will, I haven't duplicated that Bitcoin, right? It's just being represented in 2 wallets. The private key has been imported into both of those wallets, right? The Bitcoin isn't in either one of them. The Bitcoin is on the blockchain. Okay, so let's send it after all. So this one is going to be to Martin. And we're going to do a new. The UI is really tricky here to get used to. Hopefully I've got it right. So Martin, winner number 1. Right, and let's do, yeah, perfect. Just 0.01, right? And that'll be 10,000 bits or 0.01 BTC. About $5, right? Okay, send. One moment, please. Let's see. What's that? It is. I'm just very conscious of that. Ah. Just see if it all comes back. Is everything okay with the AV? I just plugged back in and it and no signal. Okay, cool. Right, so just about to send. You can see the amount that's going to be sent, 485. Default transaction fee, right, about 5 cents. Would have been the same if I was sending you 10,000 Bitcoins, right? Pretty cheap. Oh, no. Is there a way to blank the screen so I don't have to unplug?
I don't know.
Okay.
If you're not viewing the screen, you can just drag it to your
That's a good point. Aha. At least I know what I did wrong.
So it does mask the password when you're typing it, or?
Yeah, the password that I was using there. Oh, this is interesting. Watch this. Okay, here we go. Okay, good. Yeah, so I hit send just when the monitor was coming back up. It says this transaction is not yet confirmed. It's unknown how many peers have seen this transaction, right? So assuming that I do have a connection to the network, now I need one, right? Because now this client in Bitcoin J, on behalf of the client, is going to broadcast this transaction out to whatever peers it can find, basically. Ideally, you've got 8 connections or so. But if there's trouble on the network or what have you, maybe we don't have any connections at the moment. It does say we're online, so it should be OK. In any case, it'll catch up sooner or later. But we can also, let's just do a test to make sure we're online. Yes, we are. And I'll shut down, restart, see if that helps. Connecting, synchronized. I'm not sure if, there we go. OK, cool. So it's been seen by 3 peers, which basically means other people on the Bitcoin network that are running a full node, and I'll talk about what that means in a moment, have gotten that transaction that I broadcasted, and if all's gone well, they've relayed it, right? Those nodes, chances are, the nodes that just saw that transaction probably aren't miners, right? Miners being a special kind of full node. So they're going to relay it on until basically the network has been saturated and all of the miners now have this transaction in their memory pool, and they're going to wait to put it into the next block, right? So we'll get into all this terminology in just a second. But it's going to take at least, well, on average anyway, 10 minutes for the first confirmation to come in. We could get lucky, and it could be 5 or 6 minutes. But right now, even though I've sent that to Martin, and even though we can go back to this blockchain explorer and put that address in, right? Yeah, so it knows that I just sent 0.1 BTC, right? That relaying happens relatively quickly, and whatever node blockchain.info is talking to has already gotten that transaction relayed to it as well. So it knows about the transaction, but it hasn't yet been confirmed. What does that mean? It hasn't yet been put into a block. It isn't yet really part of the blockchain. So we're waiting for that. So right now, if I ran out of the room, right, Martin's money isn't really safe in his hands yet. This is one of the reasons why it's a challenge, for example, to pay with Bitcoin just like you would with a card reader at a grocery store, because that's a very quick transaction. And in actual fact, you need to wait at least 10 minutes for one confirmation. And if it's any large sum of money, you probably want to wait for a few confirmations. In actual practice, this is a problem in theory, but not really in practice, especially for small amounts like lattes and stuff like that. So if you're actually using Bitcoin to buy your coffee, mostly people just let it go. Even if it's an unconfirmed transaction, they just kind of assume honesty in these cases. OK, so let's look a little bit more at the peer network. And so just so it's on the record here, the second one to come in was Gary. So Gary, where are you? Yeah, so I'll send this once we're all finished up, right, just so we can move on. OK, so everything I just explained, so what I was just explaining about the transaction getting relayed to the peer network. This is bit nodes. By the way, everything that I mentioned on all these slides, at the end of the presentation, I'm going to give you a URL to a page on my own website that'll have all of the reference links and so on. So if you see, I'm showing you a website here, there'll be a link to that. I'll try to be pretty comprehensive about that. I'm not done yet, but as soon as we're done with the talk, I'll go fill that out, and then I'll send a tweet saying that it's done, so you guys can read that if you like. But so this site, BitNodes, is kind of keeping track of what's happening on the Bitcoin network. And it's basically, you can think of it as kind of sending out heartbeats or pings or whatever you like to all of the online nodes. And again, an online node, it could be as simple as a full node, could be as simple as the Bitcoin Core or Bitcoin QT wallet that you just saw that I had. That wallet has the full blockchain on it. It has the entire Bitcoin database on it. And if it's properly connected to the network, then it can help the network by relaying transactions and verifying transactions and so on. Right now, the Bitcoin Core client that I have on my machine isn't properly connected to the network, because I'm behind a NAT. I'm on a Wi-Fi connection, and I don't have control over port forwarding and so on. So the Bitcoin network can't find me, and that's a bummer, right? Because how many nodes are there? 7,000. As of a couple days ago, 7,200. There are a few reasons that the number's like that, but one of them is definitely that probably most people who are running Bitcoin QT haven't taken the trouble to configure their home networks to pass through, right, to forward those connections, to do the port forwarding. So in any case, that's about the size of the relay network. That is, in fact, plenty, right? The network could get away with a lot less than that. But it's always something to keep an eye on, because that number has actually been going down lately. It's gone from 10,000 to 9,000 to 8,000 to 7,000. So it's been pretty steady, but it's something to keep an eye on. This is what it looks like in Dallas, just to give you a little bit more zoomed in view. So when we sent that transaction, we probably hit one of the ones in our local area, likely as not. OK, and when we sent the transaction, you might have seen this diagram before in the Bitcoin sort of reference documentation and so on. But just to spell it out a little bit, right? This is by no means a comprehensive explanation of Bitcoin or anything like that. I wouldn't even attempt to. I'm not even sure that I could. But we can probably get this far, right? So that transaction that I sent to Martin, we had Martin's public key. Martin has Martin's private key. Martin's private key hasn't really come into play at all. We haven't done anything with that yet. He just sent me his public key. And I said, OK, with my, will this work? Oh, cool, right? So so if I'm owner 1, right? I'm the owner of 1 beams, that Bitcoin address, right? I'm going to sign this transaction with my private key. It's actually better to look at this transaction to do it. So let's say that I was owner number 2, right? I'm going to sign this transaction with my private key, the private key for 1 beams. I'm going to sign a transaction that takes Martin's public key as input to a hashing algorithm. And the other piece of the input is going to be the hash of the last transaction. So those two things together plus my private key to sign the whole thing, to cover that whole transaction and say, I'm the owner of the Bitcoin that I'm transferring right now, and I'm transferring it to owner number 2, to Martin. Right? And then so on and so forth, right? If Martin ever spends money out of that address or out of any of its unspent transaction outputs, that's the correct terminology, but we can shortcut to say address here. If he spends any of that money, right, he's going to sign another transaction, and that, kind of connection of transaction is going to keep going on. And the connection between them is that you're always including the hash of the last transaction as you go. So that transaction maybe still might be confirmed by now, we haven't looked, but that transaction might still be sitting in the memory pool, right, waiting to be put in a block. The way it's going to get put in a block is a miner, right, is going to take that transaction, it's going to run a script against that transaction, right? Bitcoin has this built-in scripting language that explains what kind of transaction this is, exactly how you should verify this transaction, and so on and so forth. So it's going to run through that script against that transaction. It's going to say, hey, everything looks valid. This isn't a forgery of some sort, whatever. So I'm going to put it into the next block, the block that I'm trying to build and solve right now, which contains our transaction, my transaction to Martin, and who knows how many others. Could be hundreds of other transactions. We're going to apply this little piece of kind of a hashing math to all those transactions just to get to a compact single hash. That's what this Merkle root is. So all of those transactions, all of their hash values are kind of combined into one, right? And then that Merkle root plus the hash of the previous block, right? This is the chain in the blockchain. All gets put together in this block. And I'm not going to explain the entire thing here, probably just because we don't have time. But then that miner is going to try to solve the block, right? What does that mean? Well, it's actually very similar to the problem that we were just solving. We're trying to get this S2GX in the right position. Well, the miner is trying to take all of that information, all of those transactions, their summed up Merkle root, the hash of the last block, and it applies one big hashing function to all of that. And then it looks at the number, right? And if that number is over a certain value, then the block is not solved. Try again, try again, try again, try again. But here it's not randomness. It's not just a random number that's being thrown in, not in quite the same way we were doing here, but it's a nonce, right? Just a number that one way or the other the miner makes up. Could indeed be from a random number generator similar to what we were doing. But in principle, it could just be incrementing. 1, 2, 3, 4, 5, 6, 7. Trying another nonce against all the same hash values. And pretty soon, sooner or later, and it might take a really long time with how difficult the Bitcoin network is these days, it'll finally get to a hash value that's under the target, right? And how that ends up being expressed is by this bunch of leading zeros, right? So it's a small enough number. The miner says, I did it, I solved it, and just like you sent me an email, it broadcasts the block to the network, and it says, I'm the first one. I worked really hard. All of these transactions are valid. I found the right combination of a nonce and all of that hash information, and this is a solved block. And every other miner on the network gets that and goes, damn. He beat me, right? And now it's all game theory, right? All those other miners could collude and say, just even though it's valid, even though it's a solved block, throw it away because I want to solve my block, right? But that would only work if every other miner on the network was doing that. The whole network would come to a crashing halt. The best thing to do is just act honest and say, well, I'll try again. I'll throw away whatever block I was working on, and I'll start a new one. Right? And I'll hope that I get it the next time. So what you end up with, right, when you do that over and over and over again, is you end up with this big chain of blocks, right? Right now we have about 319,000 of those blocks all chained together. So somewhere around 21 gigs the last time that I looked. Every once in a while, a fork happens in the block, right? You can kind of watch where somebody thought they had the right blocks solved, and then they realize, oh, actually the rest of the network disagrees with me, and they abandon those blocks. And then they always go with the longest chain. And so that blockchain, that database, right, it really is just a special kind of database. It's maybe even kind of like a graph database, is co-located all over the planet, right? At least at those 7,200 nodes that we just saw on the BitNodes website. At the very least, at those 7,200, probably hundreds and hundreds, maybe many thousands more for all the people that are behind NATs. Right? At least at those locations. So, summing up a little bit, right? So what is Bitcoin for those that are, maybe not so initiated, right? Well, it's definitely decentralized. Almost everything we just did happened in a peer-to-peer fashion. The only thing we did in a centralized service or website was just looking at the blockchain in a convenient web app that explores it, right? In principle, we could have had something on our desktop that does that too. So it's definitely decentralized. It's trustless, right? I didn't have to know or trust Martin. Martin didn't have to know or trust me. We didn't have to exchange any information beforehand other than just the address itself. I didn't have to, verify my citizenship at a bank or something like that, right? It's neutral. Neutral in the sense that it's not beholden to any particular, political affiliation or geolocation or nation state or any of that, right? It works the same way all over the globe. It's open source, right? It's, on GitHub, Bitcoin Core is, and, everything else that we've touched, right? Multi-bit, Hive, all these things are, in principle, not every single client would be open source, but in practice, most of them are. And certainly Bitcoin Core is. And maybe most importantly, it's a protocol, right? And I realize this is, review for probably many of you in here, but I think we would all do well to repeat this over and over and over again if you're talking with somebody about Bitcoin. It's a protocol, right? Imagine how many of those adjectives apply to other protocols on the web and on the internet, right? SMTP, HTTP, et cetera. They exhibit some of these things. They're certainly open. They're certainly neutral. They're certainly protocols, right? Whether or not they're trustless depends on what you're talking about. They have varying degrees of decentralization. SMTP is, in principle, pretty decentralized. That's in stark contrast to, sometimes you hear, like, I got asked the other day, like, how is it working for Bitcoin? Which was wrong on a couple of levels as a question. One, I don't have a job at all right now. And two, Bitcoin's not a company, right? So it's a protocol. It's kind of like asking, how is it working for HTTP if you're a web programmer, right? So put that all together, and what we have is that Bitcoin is the protocol for money that the web never had, right? And actually, if I remember this anecdote right, Tim Berners-Lee, right, creator of the web, was on record somewhere saying that they always meant to get to that, but they never had the time. Yeah, they might have had a hard time of it if they did try, but this is for some people this has always been a goal, right? To have this kind of money, currency, whatever you call it, that basically works like the rest of the internet. So with that said, and we'll see how much time we have left. I actually burned a lot of time, unsurprisingly. In the rest of the talk, I want to talk about, I want to branch out a little bit from Bitcoin. We'll come back to it through and through, but something that I noticed is I spent a lot of time in the community and hanging out on IRC and getting to know different developers and looking at the people and the projects that are going on in this space. That notion of decentralization and the virtues of decentralizing things, it really goes beyond Bitcoin itself, and there's a lot of activity in that space, different projects that are intent on decentralizing different aspects of the web and the internet at large. And sometimes it feels like this. You hear people getting pretty excited about this, Decentralize all the things. Well, like what? Just throwing out some examples that might be more or less familiar, right? Email. Well, email, SMTP is fairly decentralized as a protocol, but in practice these days, we've siloed ourselves, right, into just a few providers. It's definitely convenient to do that. Great features. There's nothing even wrong with it, right? I have a Gmail account too, but it's pretty darn centralized. these days. So for example, just throwing a name out there again, I'll put links to everything. I'm not going to go into detail on any of these on this slide. But one such effort is BitMessage. So like a replacement for email that works in a lot of the same ways as Bitcoin does, where everything's end-to-end encrypted, even the metadata, right? Totally sort of zero knowledge system. Better than PGP, right? Because it's not just encrypting the message body. Storage, right? So another good example of a really useful centralized service is Dropbox, but it's really centralized. And there are frustrating things about Dropbox for me, and maybe for you too. Like, it's all stored in the clear, right? They just never bothered to get around to encrypting, what's on my Dropbox. And, I wish it were, right? My disk is encrypted. Why wouldn't my shared storage be? They don't seem to be interested in that, so far as I know. So Storj, I'm actually not sure how they're pronouncing this, but I think it's Storj, is a project that wants to decentralize. You can think of it as a decentralized Dropbox, a peer-to-peer Dropbox. If we have some time, I'll talk a little bit about that in a moment, right? Obviously, Bitcoin itself is the decentralization of money itself. Social media examples like Twitter, there's a Twister is out there, right? Which, yeah, anyway, you can look these things up. But it gets really interesting really fast. Even the idea of decentralizing the entire notion of companies and corporations, this often called decentralized autonomous organizations or decentralized autonomous corporations, actually explore what we can do to create completely autonomous entities that run businesses and transact and do business and pay dividends with nobody at the wheel, right? It's the driverless car of businesses. So why? Why would you bother with all this? Well, at least these reasons, right? Freedom, privacy, greater prosperity, certainly resiliency. Just think about the internet itself, right? From the very birth moment of the ARPANET, why was that built, right? Why was packet switching developed? It was all to avoid a nuclear attack. It was so that the command and control systems of the US military wouldn't go completely down, even in the most catastrophic nuclear attack. You couldn't kill the internet if you tried, right? That's a pretty cool thing, and it really works, right? Only if you keep it decentralized, though, right? You can definitely have the equivalent of a nuclear attack, even on something like AWS, right? AWS is plenty, distributed at least, right? But there have been outages. So it's not as resilient as the entire internet, at least. Yeah, competition, right? It's great if you have lots of people, trying to do the same thing in different ways. That's better for users, right? But with so there's maybe some good reasons for it, but there's huge challenges as well. One of those is funding. How do you, when you build something like a peer-to-peer network and an application like Bitcoin, that's not, how are you going to get VC funding for something like that? You're basically building public infrastructure in a lot of these cases. So we really need to rethink how we fund these projects. It's probably not going to come through VC in a lot of cases, even though there is a lot of VC money being poured into Bitcoin as we speak, hundreds of millions of dollars in just the last year. So, my observation has been that a lot of people have seen the promise, right? Some really good things that could come of decentralization, and they're really interested in rising to the challenge. And so, for the rest of this talk, I'm going to talk about a few areas for however much time we have left, where I've seen decentralization trying to be applied or where it could be beneficial, and in many cases how Bitcoin is kind of the catalyst for that, how it actually in some cases is making possible what wasn't possible before. Let's talk about privacy, right? That's certainly in the news, on everybody's mind. Thanks to this guy, we now know for sure that this program never really went away. Anybody remember this? Total information awareness. It's about 12 years old now, right? 2002, this project was finally shut down, 2002 or 2003. But that project was every bit as ambitious as its logo is creepy, right? That Scientia est Potentia is not science is powerful, right? That's knowledge is power, right? Knowledge is power. So we're going to capture all the signals, total information awareness. And it actually so happened that that got shut down because the people saw the logo and they were like, bad idea, right? The press, the media, the people hated that. I don't know why you would create a logo. I don't know why you would publicize it, right? But in any case, we were told that it was shut down. Okay, never mind, right? But of course, we know for sure that these guys, right, the NSA and GCHQ, are using all these projects, engaging in these projects, usually written in all caps, usually sounding very masculine, to capture all the signals all the time and put them in facilities like this and process them. So who knows where this is? Yeah, it's the Utah, Bluffdale, Utah, right? The originally called, according to Snowden, the Massive Data Repository, but it was then renamed to the Mission Data Repository because the former was just a little too creepy. All right, so in other words, surveil all the citizens. So the question now is, what do we do about it? We definitely know it's happening, right? Without a doubt. What do we do about it? Well, answer number one of late seems to be nothing, right? You see this sort of thing altogether too frequently, right? Privacy is dead. That was nice. Privacy, epitaph, dawn of man until now, rip. I think we can do better than this, right? The common refrain is that it's all, what do you have something to hide? If you don't want people to find out about what you're doing, maybe you shouldn't be doing it, right? That's Eric Schmidt. Look, privacy has nothing to do with having something to hide. It's about control, right? And either you have the control or somebody else does over your private information. That's the first point, right? That's Bruce Schneier saying the same thing, right? The debate isn't security versus privacy. It's liberty versus control. Security versus privacy one is really a false choice in the end. And second, maybe it is about having something to hide. I bet every single person in this room and everybody else on the planet has something to hide, right? There's a reason we don't have cameras in our bathrooms, right? That's something to hide and has nothing to do with being illegal, right? This is, I just found this the other day. I'd never seen this before. This is the UN's Universal Declaration of Human Rights, written in 1948, right? Declaring unto the world, and to all the signatories of this document at least, that people have the right to privacy, right? Seems like a pretty good idea. And we know this one, right? You've probably heard this one. Those who would give up essential liberty to purchase a little temporary safety deserve neither, right? That's Benjamin Franklin. This is old stuff, right? And it's a difficult problem, right? I don't mean to make light of the problem completely, but the solution is not giving up. So, answer number two, protest, right? Let's, take to the streets. Which sort of, amounts to asking nicely. Maybe. I don't want to make light of this one either. I appreciate those efforts, right? That's absolutely worth doing. But is it going to be the difference maker? Personally, I don't think so. I think that what that tends to do is drive things underground. They were already underground, and they just, a whistle was blown. But just the recent stuff with Facebook, right? Just raise your hand. Are you familiar with the researchers at Facebook who were manipulating the timeline? You guys remember the story? A few people, yeah. And that was academic research that was published in a journal, right? And they're saying, here's our findings and so on. And what do you think the reaction is when the entire world says, hey, that's really bad, please don't do that? Well, they're going to fire those researchers or just not allow them to publish anymore, right? But they're definitely going to keep manipulating the timeline, right? Their job is to get you to buy things. So any way that they can do that, they're definitely going to do it. So I agree with this guy. Don't blame the NSA for being the first one to buy a hammer off a store shelf. Anybody can do this. Anybody can surveil somebody for a shockingly low amount of money. You could set up a camera on a street corner and have an NSA in a box, right, for a few $100 a month, right? And probably for far less than that if you're a government organization, right? Jeff, by the way, is a former, maybe still current, but I think former, longtime Linux core, kernel developer, and these days he's one of the primary developers on Bitcoin Core, right? So here's somebody who really cares about this stuff, saying, hey, maybe that's an ineffective path to take, right? Here's another answer, right? Or at least a partial answer. We can do what we can to decentralize, right? This is a document from the Muscular project revelations, right? How many have seen this before? This is a really famous one, right? Yeah, a few people at least. But actually, a whole bunch of people didn't, so I'll quickly explain it, right? This is a document, basically like a Post-it note, that was taken out of, I think it was taken out of GCHQ. I'm actually not sure if it was the NSA or not. But they're basically saying, hey, here's everybody who's a Google user. Here's all of their internal stuff. Here's this Google front-end servers, right? That's where the traffic is going in between. And we figured out how to remove SSL. In between, we could just read everything, right? SSL removed and added here, right? Traffic in clear text here. All your base belong to us, right? Now, that's a bummer, right? But that's, again, another hammer off of a store shelf. It shouldn't be that easy, right? The reason that that's such a problem is because there are millions and millions and millions of people using that one same centralized service. So decentralizing, right? A lot of people using a lot of different services isn't like the answer to surveillance, but it sure makes it harder, right? It increases the cost. It makes it just that much less feasible. So it's at least worth considering. And then the fourth answer that I'll offer here is encryption, right? You familiar? And we all know that we can encrypt our communications, but it's like totally theoretical for probably almost every one of us in this room, I mean myself included most of the time. This is a famous document, 1999, Why Johnny Can't Encrypt, right? They put a bunch of people in a room with PGP 5.0, and they say, encrypt a message, sign a message, go find people's public keys so that you can encrypt a message and send it to them, and all that. And I just find this just dismally bad results. Nobody can do it. Trained technologists, career engineers, couldn't get it within the 90-minute limit or whatever the experiment was, right? Just absolutely atrocious usability. 2005, Why Johnny Still Can't Encrypt, right? Another similar effort. And today, well, there's perhaps some promising stuff on the horizon. At least some interesting new ideas that are worth looking at, right? So Keybase says, hey, PGP might not be perfect, but what if everybody had a public key? What would happen if everybody on, like to some approximation, everybody had a public key, and it was really easy to find, and it was really easy to know for sure that it was the right public key? What would happen then? Well, would people start encrypting their email? Would people start using OpenPGP and so on and so forth? Well, maybe, maybe not. But people might start actually building apps on top of infrastructure like that. People might start thinking about encryption from the beginning to the end because they, for once, have the kind of safe assumption that people have a private key. That would be cool. All right, and of course, we can use Tor. Probably almost no one does. And far fewer are actually running a Tor exit node to support that network. But just to throw it out there, right? Not to go too deep on this, but if you don't know about the Tor browser, that's out there, and that's relatively new. And it's quite convenient, right? Just a browser that comes up, it's based on Firefox, connects you to the Tor network. It's great. I mean, Tor is slow, and that's an adoption problem. But if you actually want to be, to have your privacy and be anonymous, it's much easier these days with the Tor browser. Right, so there's our options on the what can we do about privacy? I say that the first two are giving up is certainly not the answer. Protesting isn't the ultimate answer. Maybe some combination of decentralization and encryption would be nice. But I think the problem is that there's no incentive for people. There has been no incentive for startups to build apps like this. One reason, one cause, I assert, is advertising. Right? This is a great article. I'll link to it. The Internet's Original Sin, which talks about basically the path that we took down, this dominant, ubiquitous funding model that we have of eyeballs on web pages, and then VC money backing that. It creates a situation where, of course, the users are the used. right? And it's not really about serving the user. So this is a quote from that maybe it's time to start paying. And that just seems like such a non-starter, right? But yeah, maybe a few people can do something about it. What does it take to have just a critical mass of people doing this? If just enough people care, right? We're addicted to all these free services for good reason. They're really useful and convenient. And they survive on advertising, which is just pretty much exactly to say that they survive on surveillance. And I think this is a true statement, right? Free is a lie. It actually comes at a very high cost. It comes at the cost of your privacy. And I recommend, I'm taking that line from a guy named Errol Balkin, who sort of coined the term as far as I know. And he's working on some very interesting stuff in this space. I hope I can get to it before we have to go. But in any case, it'll be in the notes. So we have this situation where we kind of have this two-headed beast, right? We have government surveillance that we definitely know is happening. We have, if we think about it, if we're honest with ourselves, we have this opt-in corporate surveillance. So the two alone are bad enough, but really the one enables the other, right? We make it so easy for the government to surveil us because we're doing everything in the clear in these one throat to choke kind of silos. So if only there were another way, if only, I don't know, if there were some kind of economy where people paid money in exchange for value. This is totally radical. It's never been done before, right? But just to give a couple of examples. This is a pin board. Anybody familiar with pin board? Yeah, so it's delicious. You remember delicious links, right? Just one of the simplest imaginable services, just a bookmarking service. And this service has been running for 5 years since Delicious was announced that it was going to be shut down or abandoned or whatever. So since 2009, it has exactly one employee, the founder. There's never been any other. Steady stream of $200,000 a year for the last 3 years of that service. The payment model, if you can read it, sign up now for $10 and change. That's once, right? Just sign up, pay $10 and use it for the rest of your life, right? And that gets him this steady stream of money. It makes you wonder, what else could you do that with? Could it be that simple? Could it be that easy? Well, it's worth thinking about, right? And by the way, that's their privacy policy, right? I do not share individual user data. This will never show ads. It's just like so delightfully simple. And compare that to Twitter. It's like, I just got another email from them that it's just obvious that they don't have my best interests in mind. I'm a Twitter user, right? I get it. I love Twitter too, but maybe there are other ways. Tell me, do we stop on the hour at 4? But that's when we're supposed to stop, yeah? Okay, great. I'll make sure I'm not keeping people. So here's a little bit about Errol Balkin and team's work, the guy who's asserting that free is a lie. This is the kind of teaser for a project that he's working on that they call IndiePhone. Really, really ambitious. Has anybody heard of this? Yeah. Well, hopefully a few more will hear about it now. So it's a really ambitious project to basically create a fully featured, absolutely modern, competitor to the best that Android and Apple have to offer, with a completely new OS, right? All free software running it, and from a steadfastly design-first point of view, right? It's really obvious at this point, after all these years of free software and open source, we've never gotten the user experience right. Free software and open source software is for enthusiasts, right? It's for us. It's not for everybody else. So these guys want to fix that, right? They want to build some world-class hardware and software and have it be properly free software, right, under the GPL. And it's a pretty radical idea. Absolutely no idea how it will go. We'll see, but they're on their way to a crowdfunding campaign and so on. It should be really interesting to watch. So I have high hopes for that. That would be really cool to have a phone that I knew wasn't tracking me everywhere I go. Let's see. So we have 10 minutes, and what we should probably do, I have many slides left that we're not going to get to. But we should definitely see how our transaction is doing. And then see if we, take some questions. So that was Martin's address. 6 confirmations. Oh, sorry. There we go. Yeah, so I know that's a bit small, but right. So that was Martin's address. You can see that up there, and 6 confirmations, right? So what does that mean? That means that probably very shortly after the last time we left it, that transaction got put into a block. It was a valid transaction. The whole block was valid. The rest of the network accepted it, linked it to the blockchain, right? And then the next block started being worked on, and the next, and the next, and the next. And it must have been roughly 60 minutes since we started, because there have been 6 confirmations, and the Bitcoin network makes sure that blocks are put together roughly every 10 minutes. So at this point, that's the gold standard, right? 6 confirmations, and you can be basically guaranteed for sure that, that those Bitcoins are safe and now absolutely in your hands, Martin, right? For such a small amount of money, 1 confirmation would have been fine. But if this had been, $1 million house sale, 6 confirmations is plenty. No one's going to be able to rewind the blockchain. No one has the computational power to do that. By the way, for the Git users out there, right, I often like to think about the blockchain like Git, right? Like, nobody can rebase the blockchain more than 6 commits ago. It's just way too hard for all that computational power. OK, so that's probably a pretty good place to stop, even though I probably have 3/4 of the presentation left. Let's take some questions. Yeah, Dave. The analogy, so the analogy was good. What analogy? Ah, yeah.
It seems to me like there's something in between that is, it's probably already there. It probably exists and I don't know what it is. But if you're talking about a transaction or fundamentally, Git is something that's decentralized and shared. And, you could build a consensus model, you could build a cluster state machine out of Git, or you could build one out of Bitcoin, right? And the difference would be that the Bitcoin one would be cryptographically guaranteed to be accurate, whereas the Git one you sort of, maybe you risk falling over.
That's exactly right. So yeah.
Something else, right? What actually is it that I'm trying to grasp here? I don't know what I'm trying to explain to you, so I'm hoping that you'll explain it back to me. What is the difference between a set of commit IDs that are linked to each other and can't be unlinked?
Yeah. Yeah, it's an interesting question. So what is the fundamental difference between the sequence of commits in a Git repository and the sequence of blocks in the blockchain? That's a good one. Well, a few ones are obvious, like the cryptography, right? Like Git is just SHA-1. I mean, it's actually quite easy to find a hash collision and replace a Git commit if you really wanted to. And that's why, by the way, you can sign your Git commits now. Yeah. But yeah, you probably wouldn't, right? It's a sort of theoretical problem that no one would do. But the fundamental difference is the securing of the network by all of these miners, right? That action of working really hard to solve that puzzle and then finally getting there has this. It's a notary service. It's a time-stamping service. It's saying that this is definitely a correct set of blocks. I worked really hard to get to it. I beat everybody else to it. Everybody else agreed on it, right? There's just no similar mechanism in Git because there doesn't need to be, right? But you could, in principle, build it, right? I mean, you could build a blockchain-like, variant of Git. It would be totally useless, but.
Yeah, well, I'm just kind of sense there's something in between that wouldn't be
Yeah. Well, good. Let's build it. Another question? I think, yeah.
Yeah, actually, we have a comment and a question. So my comment is, there's a recent theory when looking into WikiLeaks, Julian Assange. So if you guys are interested in why decentralization is important, I mean, he lays out basically all the argument for the very, very nice. So highly recommended. I think it came out in like a month.
So the book recommendation is When Google Came to WikiLeaks by Julian Assange, and it's laying out the case for decentralization by Assange. That's cool.
So that's the comment. And the question
Yeah.
is, if you have anything to say about Bitcoin,
Yeah. The question is, do I have anything to say about Namecoin? Not really. I do own a .bit address, right? So Namecoin is a fork of Bitcoin Core that does something completely different than what Bitcoin does. It's not about money. It's about a decentralized domain name system, and it's quite interesting. Of course, you have to be going through Namecoin-aware name servers in order to resolve Namecoin TLDs, right, top-level domains, of which there's only one, so far as I know, and that's the .bit TLD. So I have a .bit address, but it's just kind of like I did it for just to see what it was all about. I don't have any strong opinions one way or the other. You can't possibly be doing cryptography to.
What is it that Bitcoin adds to that in a distributed network? What problem do I have to solve?
So in the case of Namecoin, what makes the kind of like how Bitcoin thinks about things and how Bitcoin does things, why that's useful to kind of graft onto a domain name system, is that again you have this decentralized notary function that says this person bought this domain at this time for this much money, which, by the way, you buy them in Bitcoin. And that's definitely his, right? And so there's a blockchain of domain names out there, and it's a perfectly auditable thing, right? I mean, it's actually, in principle, it's much better than whatever you deal with different nicks and so on. Just one sec. Since we have like 2 minutes, I'll see if there's like one more question that we could answer. Yeah? Sorry? Who gets the transaction fee? That's a really important one. Miners do. So that transaction fee actually ends up being just kind of like a line item in that block, sort of just another transaction that gets paid to the miner in much the same way that a miner actually creates a transaction to pay himself if he solves the block. That's how Bitcoins are created, right? 25 Bitcoins get paid to me if I solve the block first, and everybody agrees to let them have it, and 25 new Bitcoins are born. Yeah, go ahead. Yeah. So what's the killer app for Bitcoin? What would cause it to be much more popular, right? That's the question. And I think it's a very interesting question because I wonder these days if it's the right question. Everybody wants adoption to happen, right? When are we going to see this hockey stick of adoption? The whole world uses it, and well, if that happened, that might be a great thing. But I'm not sure that that's what we need to go after. I think on a long enough timeline, it's going to happen. So let's keep getting the infrastructure right. Let's build really usable software. Let's use it ourselves, right? And welcome everybody, right? And have great documentation and so on, but not go too crazy trying to get mainstream adoption. I think that's also a valid path. We have time. It might take time. I mean, think about the web. 25 years later, right? How long did it take to get a really good browser? A while, right? Netscape was the killer app at the time, but that wasn't a really great browser. That took years and years. It might be the same. Well, that's time. There's a whole bunch more stuff that I had to talk about. If anybody wants to talk, now or other times in the conference, I'm happy to do that. Really, really appreciate it. It was a total thrill for me to give this talk. Thanks. And yeah, we'll call it good. Cheers. I'll put up on the screen this URL so you guys have it. Yeah. If you want to write that down, or if you just follow me or look me up on Twitter, I'll tweet there and let you know that is populated. The page is up, but it's just a bunch of to-dos. So I'm going to go fill in those to-dos and put links to everything in the talk. Thanks, guys.